This video is on wise vector mathematical operations such as subtraction, multiplication, division, negation, and the dot product. So let's have a look at what we've got. We've got two vectors, vector 1 and vector 2. Each one has got 8 integers. And then we've also got a static method that basically display the content of the vector, showing their value at that particular index. So let's have a look at what we have. We want to do an element-wise subtraction of two vectors. So before I actually do this part, what I want to do is I want to just modify this method slightly such that it actually receives a string argument called operation name. And then what we want to do is print that out, print the value of the variable. But to do that, we have to put a $sign first. And I'll put a colon. That's pretty much it. That's all I wanted to change in this method. So now what we can do is call up the method and pass in the string subtraction. And the element-wise subtraction of vector 1 minus vector 2. Now the result will actually be a vector that has the values 1 minus 8, 2 minus 7, and so on. So let's run and see what we get. So indeed, we get 1 minus 8 is minus 7, and then 3 minus 6 is minus 3, and until we start going into the positive, so 5 minus 4 is 1, and so on. So what this returns is a vector, and that's what this method is receiving, is another vector ready to be displayed. Next, what we want to do is demonstrate the element-wise multiplication of two vectors. So I'm going to change the first argument, which is multiplication. And the second argument is a result of multiplying two vectors. So it's going to multiply 1 by 8, which is 8, 2 by 7, which is 14, and so on. Let's now demonstrate the element-wise division of two vectors. So again, what we'll do is we'll take the first argument, change it into the string division, and then divide vector 1 by vector 2. And what it'll do is it will actually give us an integer division. So if 1 over 8 is 0 point something, so because it's an integer division, so any floating numbers are actually dismissed. That's why we're getting 0 for the first 4 elements, because the numerator is smaller than the denominator. So with integer divisions, the fractions are lost. However, this is 5 divided by 4, which is 1, and 6 divided by 3 is 2, and so on. Because again, it's integer division, so we're losing any decimal points. We've also got negating all elements in a vector. So if I were to copy this line, changing the first argument to negation, like this, negation. And I might want to negate one of the vectors. So what this will do is it'll change the sign of each element in the vector. So this is useful when you want to invert the direction of the vectors, components. So if you have, say, that's negative, so let me just sort of make the even ones negative, and we'll see what happens. So now we have the alternate, so then the even ones are now positive and the odd ones are negative, whereas in the original vector, it's got the odd ones being positive and the even one's negative. So I'm just going to undo that part. Just wanted to sort of make a point here on how negation works. And then what we want to do is compute the dot product of two vectors. Now the dot product, what it does is it will, for each pair of corresponding components from the two vectors, it will multiply them together, and then it will add up all the results of this multiplication to get a final scalar result, which is going to be an integer because these vectors are integers. So we can store the result of the dot product in a variable called in an integer variable that we can call dot product, and then we can use the dot method to perform the dot product of vector 1 and vector 2. And then what we can do is display the result. I can't really pass this to the method that we have because this method expects a vector, but what we have is an integer result, which is going to be the sum of all of the corresponding elements from each vector multiplied by each other. Okay, so what we can say is dot product result, and then display the result of the product like this. So let's see what we get. I'm expecting something. Sorry, that should have been an equal to sign. Okay, so we get the value 120 because what it does is it will do 1 times 8 plus 2 times 7 plus. So pretty much it's these values that have been added up. This is the result of multiplication of two vectors. So all of these are added up to give us the dot product, which is going to be 120, which is what we get here. So that's pretty much it of what we wanted to demonstrate in this video. I hope it was helpful, and I'll see you in the next one.